So vectors question. So we're told that we have a parallelogram. That's very important because it means that the opposite sides are parallel. And remember, if opposite sides are parallel and the same length, then they'll be the same vector. So we're told that AB is the vector x, so x goes all the way from there to there, which means that I know that DC is also going to be the vector x. And we're told that AD is the vector y. I'm going to put it there, I think it's a bit clearer. And if that's the vector y, we're told that m and n are the midpoints of these sides. So if n is the midpoint of AD, then I know that that little bit there is going to be half y, and this little bit here is also going to be half y. So over here, this is parallel, so that's going to be half y, and this bit here is also going to be half y, and all the way from B to C must be y. I think it helps to get that information onto the diagram. So the first question says mn. Well, to get from m to n, I'm going to go the long way round. I'm going to go from m to c, and then I'm going to add c to d, and then I'm going to add d to n. So it's the long way round. So I'm going to go from m to c. Well, the vector mc is half y. The vector cd is going to be minus x, so let's just make that minus x. And then the vector dn is minus a half y. So we can just make that minus. Now I notice here that the half y and the minus half y cancel each other out, so mn is actually just the vector minus x. And you can really see that from the diagram. There's x. This vector here is fairly obviously parallel to each of these two. So from m to n you can see is minus x. Okay, I'm now asked to find the vector AC. Now to get from A to C, I'm going to go from A to B first, and then I'm going to go from B to C. So A to B, B to C. From A to B is x, and from B to C is y. So AC is literally just x plus y. Okay, next bit. P is a point on CP such that y is equal, so P is the point so that CP is y minus a half x. So in other words, what it's saying is that somewhere out here, don't know where, doesn't really matter, there is P. That vector that takes me from C to P is y minus a half x. And without even really looking at it, it could be anywhere at the moment. So find in terms of x and or y the vector PA. So let's just have a look at how we could find PA. So to get from P to A, I'm going to go from P to C. Let's do PC followed by CD followed by DA. Actually, I'm going to do it over here so we can see the diagram. So PA is the vector PC plus CD plus DA. And let's see what we can get there. So we already know the vector PC. Well, we know that CP is y minus a half x. So PC is going to be that in reverse. So I'm going to make it negative where it's positive. So the y becomes minus y. The minus a half x becomes plus half x. So that's PC. Now I'm going to add CD. Well, CD is minus x. So let's just make that minus x. And then DA is this one, which is minus y. So let's have a look at what we've got all together. So if I collect the x's together, I've got half x minus x. Well, if I do half take away 1, that becomes minus a half x. And then I've got minus y take away another y, which is minus 2y. So that's the vector PA. Let's just see if that's all they want. So PA is just going to be, what did I say it was? Minus a half x minus 2y. Minus a half x minus 2y.